Welcome back to Maths with Mrs. J. Time for another geometry challenge. This one's pretty easy as long as you know Pythagoras' theorem. This one is thanks to Michael Penn. I do highly recommend you follow him on YouTube. He's got some awesome stuff. This is certainly one of his easier challenges that he does. He gets a lot more complex than this, certainly. This one here, what we start with is a square of side length 1 unit. In that square, down the bottom left-hand corner, we have a square of side length 2r. Then we have two circles, both of radius r, that are positioned as shown in such a way that you can draw a diagonal from here to here, and it will go through the diameter of both circles. Our task, of course, is to find r. All right, let's have a bit of a think about this. It's really not that tricky to do if we know our Pythagoras' theorem. Let's have a look at this section first of all. So we have a square of side length 2r, and we want to get an expression for this diagonal in terms of r. Well, that's not terribly difficult to do. We have we have 2r, 2r, and x. Using Pythagoras' theorem, x squared is 2r squared plus 2r squared. So x squared is obviously 8r squared. So x will be 2 root 2 times r, using Pythagoras' theorem and a little bit of absurd simplification there. So this length here will be 2 root 2 times r. Obviously, this part of our diagonal is quite easy to work out. It's just going to be 2 lots of r. We've got a radius here, we've got another radius here. We're also going to have a radius here. The only remaining part for us to work out is this length here. Now, this is going to be a square, all right, that we're finding the diagonal of. In this case, it's r by r. So we've just got r by r, and call this y, for example. So y squared will be r squared plus r squared. It's pretty obvious that y will be root 2 times r for that diagonal there. All right, so all of that put together is going to be the diagonal of our square that has side length 1. Well, okay, side length 1, we should know by now. We probably know this off by heart, but if you have 1 by 1, then you're going to get square root 2 as your hypotenuse. So z squared is 1 squared plus 1 squared, so z is obviously root 2. Let's just pop all this together. So we know that 2 root 2r plus 3 more r's plus another root 2r. So that's all our r's that we have, and that's going to equal root 2. What does this equal? This equals 3 root 2 plus 3 times r, which is 3 lots of root 2 plus 1. Just coming up here. So r is obviously going to be root 2 over 3 root 2 plus 1. We generally like to have any surds with a rational denominator, so let's multiply by the conjugate surd over the conjugate surd. What we're going to get when we multiply out our numerator is we'll get 2 minus root 2. Then in the denominator, of course, we have our 3, and then root 2 plus 1 times root 2 minus 1 is 2 minus 1, which of course is just 1. So we end up with 2 minus root 2 on 3 for our radius. Fairly easy challenge there, as long as you know your Pythagoras, but an interesting one nonetheless.